Hello, my name is Giovanni Cornejo, and this is my final project, Rusty Vault. At the moment, it is a command line program that implements a password generator and a password checker, but I may take it further into being a full-fledged password manager in the future. I'll first start off by showing its functionality in the terminal, where I have two scripts with examples of the generate and check subcommands. So to start off, here is the generate subcommand usage. It specifies some extra options on how passwords are generated. So the default length is between 20 and 25, and if the user specifies their own length, it must be a minimum of 13. For the commands entered, the first three show off the default implementation, the next command shows the length being changed to 13, and the final command shows the minimum number of uppercase letters being set to 20. As you can see, if I run the command again, the outputs will be different. So to check the validity of these passwords, I have an external tool from security.gov pulled up to show the strength of these passwords. So let's go ahead and copy this value and paste it into here. And we see that it's going to take 28 nonillion years for a computer to crack, which is a very long time. And then if we check this smaller password, which is only 13 characters long, it'll probably be still pretty good, but easier to crack. So this would only take 2 million years, which is still pretty good. So now let's go on to the check subcommand. So for these first two passwords, the program indicates that they are common passwords, and then monkey business all lowercase is of medium strength, and then monkey business with capitalization is a very strong password. So these may seem weak, but the program bases this on how long it would take a computer to crack the password. So again, if we go over to security.gov and implement monkey business, for instance, it would take 51 years to crack that, which is medium strength because it's still a pretty long time. If we do capitalization, it takes 800,000 years. So that indicates that it's still a very strong password. Okay, now let's go into how this was implemented. So for the generate function, the generation of passwords works by first randomizing characters to reach the minimum count specified by each character set, and that is down here. And then it then fills the rest of the password up to its length with random characters from any set. That's done here. And then lastly, it will shuffle the password. So this is all done with the thread_rng function, which is a cryptographically secure random number generator. And then for validation, I chose to implement a variety of mechanisms, such as calculating the entropy of the password, which involves summing up the number of possible characters that the password can have and taking the log base 2 of that value, and then multiplying by the password length to get the entropy in bits. The higher the number of bits, the stronger the password. I also checked for character variety and for repeating patterns to determine strength. And for the smaller lengths, I also added extra checks for the strength, and I clamped that to a range between -2 and 2 to show if it's weak, medium, very weak, strong, and strong, very strong. And that is how Rusty Vault works.